Hello, is my voice audible? Can anyone confirm me whether my voice is audible? Shall we start the session? Good evening, everyone. Is my voice audible? Yes. So let us start today's session. So in this session, we are going to start with the event scheduling in System Verilog. So what is this event scheduling? Before starting with the event scheduling, let me ask you two questions. Okay, so I have two problems. My first problem is, so I will discuss first these two problems, and afterwards I will discuss the solution for these two problems. Okay, so I have two problems. First, let us discuss our first problem. What is my first problem? Let me discuss the first problem, and then after we will discuss the second problem. Okay, so yeah, so let's say we have a DUT here. So this is problem number one. Okay, we will discuss two problems what we are having here. So first let us discuss the first problem. So let us say this is our DUT. This is DUT means design under test. Okay, and this is our test bench through which we are going to test our DUT. Okay, this is our test bench. So with the help of the test bench, we are going to test our DUT. So with the help of the test bench, we are going to pass the stimulus to our DUT and receive the response from the DUT to the test bench. Right. So this is what we are going to do with the help of our test bench, right? So with the help of the test bench, we know that we are going to pass the stimulus and we are going to collect the stimulus. Okay, I will write it here. So with the help of this test bench, what I'm going to do, I'm going to drive the drive the stimulus, and I'm going to collect the stimulus. I'm going to collect the stimulus from the DUT, drive the stimulus to the DUT, and collect the stimulus from the DUT. Okay, this is what I am going to do with the help of my test bench. So what is the first step? What I'm going to do? I'm going to drive the stimulus to my DUT and collect my stimulus from the DUT. Right. For example, let's say we are writing the DUT code and test bench code in Verilog itself. Okay. So let's say we are writing both the DUT code as well as test bench code. Okay. So both these codes in Verilog itself. What I'm doing, I'm writing both DUT code as well as test bench code in my Verilog itself. What happens is, so in case of Verilog, so before going to discuss about what is happening, we will once briefly do a recap about a Verilog event scheduler. Okay, I hope you are aware of this Verilog event scheduler, which you have already learned in your Verilog. So in case of Verilog event scheduler, what happens is there are four regions where the code is executed. One is active region. So in this case, in the active region, what happens? It executes modules, process statements, evaluate continuous assignments, and primitives. These are all happening in active statements. And inactive statements, zero delay blocking assignments will happen. And in case of NBA region, which is also known as non-blocking assignments, so non-blocking assignments will take place or gets executed in case of NBA, right? So in case of monitor region, what happens is our dollar monitor, dollar strobe, that and all will be executed. So this is the case of Verilog event scheduler, right? So most of the process will happen in the active region itself. Okay, most of the most of the execution of the code will takes place in active region only. Okay, what is happening? Most of the code is getting executed in the active region. Okay. Now I'm writing both the DUT as well as Testbench in the Verilog itself. Okay. I'm writing both the codes for my Verilog as well as sorry, for my DUT as well as my Testbench in Verilog itself. Okay. So what happens? My the code or the design which I have written in my Verilog in the Verilog will be executed in the active region. Okay. The design will get executed. The design which I have written in my Verilog, the design is executed in the active region only, in the active region. And the test bench, the TB structure, the stimulus which I am going to drive will also be executed in the active region only, will also be executed in the active region only. This is what happening in the case of Verilog. So the design is working in the active region as well as test bench is also getting running, or it is also executing in the active region. So there might be a chances of race conditions when in this type of scenarios. So there are chances of race conditions. So there are chances of race conditions while, because the design and the test bench are working in the active region, so there may be a conditions of race conditions. Okay, so because of this, in SystemVerilog there are some modifications to this event scheduler. Okay, so now we are going to see what is so this is a problem one. Okay, so this is basically problem one. What is a problem one? Both the test bench and the DUT are working in the same region. Which region? Active region. So both the test bench and the DUT are working in active region. Why? Because our DUT and TB are written in the same language, Verilog language. Okay, so most of the code will be executed in the active region. So this is my problem one. What is the problem? There may be a condition of race conditions because of this same working regions. Okay, so how to overcome that? So SystemVerilog comes with a new event scheduler. This is the new event scheduler of SystemVerilog, where we are going to have some more extra regions to overcome that problem. Okay, so that was the first problem, and the solution for this first problem was event scheduler. Okay, so that is what we are going to discuss in our today's session. Okay, now, so in Verilog, almost all simulation events happen in the active region, that we have already seen. So in Verilog, almost all the simulations even happen in the active region, and leading to issues when the test bench and the design code are executed simultaneously. So there will be some issues when the design and the test bench code are executed simultaneously. In SystemVerilog solves this by dividing each time slot into several timing regions, ensuring that events happening in the structured manner. Okay, so because of this, SystemVerilog introduces several timing regions to to overcome that specific problem. Okay, so now let's see what are all the events which are present in SystemVerilog event scheduler. So first region is Preponed region. In this region, sampling of stable values happen, and active region where it will execute module process statements, evaluate continuous assignment and primitives. It is same. So it is same. So these regions are as same as the Verilog event scheduler. So these are not modified. The new ones are this yellow shaded ones. Observed region where the SystemVerilog will execute or evaluate assertions. In observed region, assertions will be evaluated, and in reactive region, execute action blocks and programs, and inactive region execute zero delay statements, and in postponed statements, it will be postponed to next time slot. Okay, so we will discuss them in detail now. So this is SV event scheduler. So in preponed region, what is happening is, this is the region the first to execute within a time slot. In this phase, signals are sampled by the test bench before any design activity occurs. So this is the main point for this is the solution for our problem one. What is the solution? Preponed region is our solution. Okay, half solution. So in this phase, signals are sampled by the test bench before any design activity occurs. Okay, so when the TB is getting executed, the TB is getting executed in the preponed region. The TB is getting executed in the preponed region. That is, the TB is sampling. The TB is sampling the signals from the DUT at preponed region. Sampling means collecting of the signals from the DUT. Okay. So the TB is sampling those signals in the preponed region. So the region is, so this is the first region to execute. So the what happens is when the design gets started. So initially, when the before the design actually gets started to execute, the preponed region starts, and the TB what it do, it will sample the signals. Okay, it will sample the signals. Okay, the design is not working at this preponed region. The design is not still started working. Okay, the design is not still started working. Only the test bench has been started in the preponed region, and the sampling is happening. Okay, since no design activity has taken place yet, the signals represent the final values from the previous time slot. Since the design is not working, so the values which are sampled are the final values. So this allows the test bench to capture the last known values before any design changes are applied. Okay, so this allows the test bench. So test bench will come to know that these are the last known values before any design changes are applied. So this is about preponed region. I hope how a preponed region is helping us to solve our problem 1. It is clear, right? Now, in the case of active region, what happens? In the case of active region, all the design events are executed. So where the design is getting executed? The design is getting executed in the active region. The design is getting executed in the active region, right? So this includes RTL code, gate level code, and the clock generation for the design. The active region is the region where the main logic of the design is evaluated. Most of the functional behavior of the DUT happens here. Okay, so the design will start executing in this active region where the test bench will not be functioning, or it will not be sampling. The test bench will not be sampling, or it will not be giving the stimulus to our, or it will not be driving any signals during this active region. Only the design will operate during this active region. There will be no operation of our test bed. Either it will be not sampling, or it will be not driving. Okay, so this is about active region. And in case of observed region, so in the observed region follows active region. In this region, assertions and other checks are evaluated. We will discuss about these assertions later in our upcoming sessions. So this ensures that any condition that should hold after the design event, such as timing constraints or protocol checks, are validated. We are going to see what are meant by these assertions in our upcoming sessions. Okay. Now, coming to next region, which is reactive region. So basically, in this case of reactive region, after the observed region, the reactive region is executed. This is where the test bench code runs. Okay, so the region where the test bench code starts running is called a reactive region, allowing the test bench to respond to the design events that happened earlier in the same time slot. For example, this is where the test bench might update its signals based on their design outputs. So basically, in this case of observed region, test bench will provide the stimulus. The TB will start executing, and it will provide the stimulus. It will provide the stimulus to our design. Okay, the TB will provide the stimulus to our design in the case of this observed region. So in the case of observed region, our DUT will not work, or our design will not work. It should not work. Okay, since the TB is providing the stimulus, or for the previous design outputs, here the TB will only work and the DUT will not work. Okay, so after the observed region, the reactive region is executed. This is where the test bench code runs, allowing the test bench to respond to the design events of that happened earlier in the same time slot. For example, this is where the test bench might update its signals based on the design outputs. So using this SV event scheduler, we are actually able to solve or give the solution for problem 1. Okay, we are able to give the solution for our problem 1. What was our problem 1? So previously in Verilog, was happening? The DUT as well as our test bench were working in the same time slot. That is, in the active region they were working. Right? There was no another region for to work. Okay. So because of this, there was a race condition. Why we are getting this race condition? Because what happens is, in the active region, if our design is getting executed, and during this execution process test bench tries to give any other new stimulus, then what happens? Should this design should work on the previous old stimulus, or should it should accept the new stimulus? It will get confused. So there will be a race condition, right? So there may be a chances of race conditions in this type of scenarios. So what was the solution that was introduced? The solution was the SV event scheduler. The SV event scheduler. So using this event scheduler, we are able to solve this problem by introducing some more slots. Okay, by making DUT to work in one region, and our test bench to work in another region. So DUT will work in active region and test bench will work in observed region. So this is about the SV event scheduler. So in this particular session we have discussed first problem. So second problem we will discuss in next session. Okay, what is that second problem? We will discuss in our next session. So that's all for this session. Thank you. So if you are having any doubts or queries, you can ping me in the chat. If you are having any doubts or queries, you can just ping me on the chat. Okay then, I think we will end this session. Thank you for watching this. Bye. Good night.